Welcome to the channel. This is our final video on the subject of comparison of motorcycle versus scooter. That is the final verdict, and it is a part 3. We shall be talking about special motorcycle features like better wheel impact resistance, superior off-road capability, better fuel economy at highway speed, longer rider range, greater cargo flexibility, better high-speed stability, and lower purchase cost versus and wider model choice. If you have not yet subscribed this channel, please do so as soon as possible. This is our video number 121 in total. So coming to the first factor, that is better wheel impact resistance. Motorcycles with larger wheels absorb potholes and road irregularities more effectively, improving ride quality, durability, and stability on poor road surfaces. The angle of attack and rolling physics, as far as a motorcycle is concerned, when hitting a pothole, a large wheel bridges the gap more effectively, rolling across the upper edge of the depression rather than falling deep inside it. There is a scooter, which has a small wheels. It drops completely into the center of a pothole, thus transferring a severe, violent, vertical shock wave directly into the vehicle's chassis. The rotational inertia and gyroscopic stability. Larger motorcycle wheels generate significantly higher rotational inertia, that is, gyroscopic effect at speed, than hitting a sudden bumps or rock. This spinning mass naturally wants to stay upright and track straight, resistant deflections. A scooter's small wheels have very low rotational inertia, meaning a sharp impact can easily deflect the front wheel sideways, compromising stability and increasing the risk of a crash on poor surfaces. The third important element related to the impact resistance is component durability and tire cushioning. Because smaller wheel drops into the road hazards, its tire casing is frequently pinched tightly between the harsh pavement edge and the metal wheel. This exposes scooter to a much higher frequency of bent rims, cracked alloy hubs, and tire sidewall punctures, that is, blowouts. Motorcycle wheels distribute the impact energy across a larger rim circumstances and a taller tire sidewall, providing a natural rubber cushion that preserves the integrity of the suspension and steering components over time. The summary: potholes mechanics. In case of motorcycle with the wheel 71 to 21 inches, bridges and rolls over road depression. Where in case of scooter, small wheel diameter drops deeply into gaps, striking sharp edges. Chassis shock wave, mild to moderate, absorb smoothly, whereas in case of scooter, violent and abrupt, high impact transfer. Gyroscopic stability, as discussed, is high in case of motorcycle and low in case of scooter. Rim and tire damage risk. low in case of motorcycle, and high in case of scooter. Here is an infographics, but that is what we have discussed. That is feature pothole mechanics, motorcycle bridges and rolls over road depression, whereas scooter drops deeply into gaps, striking sharp edges. Likewise, chassis shock wave absorption, gyroscopic stability, which is high in case of motorcycle and low in case of scooter. Rim and tire damage risk, low in case of motorcycle and high in case of scooter. Larger wheels, less shock, more control in motorcycle, and smaller wheels, more shocks, higher risk in case of scooters. The next important factor, which is for the comparison, is superior off-road capability. Motorcycles are better suited for dirt roads, gravel rural routes, and light off-road riding, thanks to their larger wheels, stronger suspension, and high ground clearance. Under the same factor, superior off-road capability, one important feature that is advanced suspension geometry and travel. Motorcycle utilize long travel front forks and a sophisticated rear monoshock attached to rugged swing arm. This the bike is then this long suspension travel allows the bike to fully compress and rebound over deep ruts, larger rocks, and uneven dirt paths, keeping the chassis stable and absorbing severe impact without bottoming out. In case of a scooter, CVT transmissions are integrated directly into the rear swing arm assembly. This rear suspension carries immense upspring mass. This heavy layout prevents the rear shock from reacting quickly to rapid bumps. Combined with short suspension travel, scooters easily bottom out on rough, unpaved paths. Second factor is larger diameter off-road tires. Motorcycle with the specialized seat patterns bite deep into loose soil, mud, sand, and gravel to maintain traction. Scooter with a smaller wheels on a short road, small tire easily wash out, spin fruitlessly in loose dirt, or become trapped in shallow mud ruts. Now, the final comparison, that is suspension level, it is okay for long travel in for motorcycle and in case of scooter, suitable for short travels. Upsprung rear mass, low in motorcycle and high in case of scooter. Tire adaptation readily accept knobby, high traction off-road tires and in case of scooter, restricted to shallow groove street commuter tires. Road ergonomics, excellent, allows standing on pegs for weight control and restricted in case of scooter with fourth seat position reduces control on dirt. This can be further explained through this infographics regarding suspension travel in upsprung rear mass, tire adaptation, and rider ergonomics, as discussed before. Now coming to the next factor, that is better fuel economy at highway speeds. Manual gear selection allows the motorcycle the engine to operate at lower RPM during cruising, often delivering better long distance fuel economy than CVT equipment equipped scooters. Further details, motorcycles utilizes a manual transmission with fixed positive engagement steel gears. This creates a direct, high efficient mechanical link between the engine and the rear wheel, operating with minimum energy loss. In case of scooter CVT, it uses a rubber belt riding between sliding metal pulleys. At high speed, the belt is forced to the outer edges of the pulley, which creates significant continuous friction and heat. This continuous belt slippage and mechanical friction results in parasitic energy loss, reducing overall efficiency. Then come to RPM management and engine longevity. Because motorcycle has a fixed top gear, the engine can maintain high road speed while keeping its revolution per minute relatively low and relaxed. In case of scooter, by design must spin the engine much faster at high speed to keep the belt expanded against the pulleys. It burns significantly more fuel and increases internal thermal stress. Coming to the aerodynamics and power demands. Motorcycle naturally position the rider in a forward leaning stance, which cuts through the air more cleanly at higher speeds. Scooter force on upright, feet forward posture acts like a sail, increasing aerodynamic drag, thus consumes more fuel to overcome wind resistance on the open road. This can be summarized as transmission link in case of motorcycle, direct steel gears, and in case of scooter, high friction and heat loss because of rubber pulley, rubber belt, and pulleys. Cruising RPM, lower optimized in motorcycle, high in case of a scooter. Highway fuel consumption, highly efficient, whereas in case of scooter, elevated, drops significantly compared to city usage. Aerodynamics profile, lean aggressive, lower wind resistance in case of motorcycle, and upright position, open and higher aerodynamic drag in case of scooters. This can be further explained and can be seen in this infographic that is transmission link, cruising, engine RPM, highway fuel consumption, and aerodynamic profile. Motorcycle have lower RPM, lower fuel use, and with more kilometer. In case of scooter, higher RPM, higher fuel use, and more cost. Coming to the next factor, and that is longer riding range. Larger fuel tanks in case of motorcycle enable it to travel significantly farther between refueling stops, making them more suitable for touring and long distance journeys. Motorcycles have high capacity fuel tanks because motorcycle place the fuel tank extremely mounted high up on the frame top tube between handlebars and the rider. Because this area is open space, manufacturers can fix and fit larger fuel tanks, typically ranging from 12 to 20 plus liters. Whereas Kershaw scooter must squeeze the fuel tank into the tight space beneath the footboard or under the right seat, restricting its capacity from 4 to say 8 liters. The total range and routine planning flexibility. Thanks to the larger tank capacities and better high-speed fuel efficiency, a typical motorcycle can easily cover 350 to 500 kilometers on a single tank of fuel. This allows riders to confidently travel through remote regions or across long highway stretches without constant range anxiety. But in case of fueling, frequent refueling stops, a standard urban scooter often needs refueling after 120 to say 20 220 kilometers. On the long distance trips, this requires frequent stops and careful route planning around available gas stations, restricting where and how far you can travel comfortably. Third factor is cargo independence. In case of motorcycle, it can pack side panaries and tall bags of and tail bags full of gear. In case of scooter, a slightly larger fuel tank often means sacrificing critical undersea storage space, forcing a trade-off between fuel range and luggage capacity. This can be summarized. Tank placement is, in case of motorcycle, is external and scooter, it is concealed. Typical fuel tank capacity, larger in case of motorcycle, say 12 to 20 plus liters, and in case of scooter, smaller, say 4 to 8 liters per tank. Average range, extended 350 to 500 kilometer plus, whereas in case of scooters, it is limited by 150 to 200 kilometer. Scoring stability, high, ideal for long distance remote routes, and in case of scooter, low to moderate, best suited for urban routes. All these factors are further explained in this infographic, that is tank capacity, typical tank capacity, tank placement, average range, and scoring suitability. In case of motorcycle, bigger tank, longer range, and total freedom. In case of scooter, smaller tanks, shorter range, and more stops. Coming to the next factor, and that is greater cargo flexibility. Motorcycle can easily accommodate saddlebags, panaries, tank bags, crash bars, luggage racks, and touring accessories providing greater carrying versatility. Motorcycle, the rigid skeleton of motorcycle provide solid anchor points for attaching fixed panaries rack, top box mounts, tank bags, crash bars, dry bags, and tail bags. In case of scooter, prioritize integrated enclosed storage, the underseat bucket, adding heavy external luggage is difficult. Tailored weight distribution for handling. In case of motorcycle, a rider can balance heavy item across multiple zones, placing a heavy tank bag over the front center, hard panaries on both sides, and a tail bag over the rear axle. This spreads the payload across both wheels, preserving front wheel traction and steering control. In case of scooter, all cargo on scooter must sit behind or beneath the rider seat. Adding extra luggage, concentrate all the payload over the rear axle, which stabilizes the scooter, destabilizes the scooter, making the front steering light and unpredictable, especially at highway speeds or under heavy acceleration. The third factor is specialized accessory ecosystem. Due to their open frames architecture, motorcycles enjoy a massive aftermarket ecosystem of heavy duty accessories. For example, hard and soft panneries, tank bags, crash bars and fork bags, and tie down versatility. This discussion can be summarized in, that is, first one, primary storage type. In case of motorcycle, modular and external. In case of scooter, integrated internal. Weight capacity, high in case of motorcycle, moderate in case of scooter. Weight distribution well balanced in case of motorcycle, evenly across front, center, and rear. In case of scooter, heavily biased toward the rear wheel. Customization is extensive in case of motorcycle and very limited in case of scooters. This can further be seen in this infographic, that is storage type, weight capacity, weight distribution, and customization. Motorcycle, more capacity, better balance, and total freedom. Scooter, limited space, rear heavy, fewer options. Coming to the next factor, and that is better high speed stability. Motorcycle longer wheelbase, larger wheels, and optimized chassis geometry provide superior stability during high speed riding, cornering, and two up touring. Motorcycle features a longer wheelbase, that is the distance between front and rear axle center, paired with high rake steering head angle, and trail. This geometry layout produces a high straight line tracking ability, making the vehicle resistant to sudden wind gusts, road grooves, or high speed wobbles. In case of scooters, they are engineered for maximum low speed agility in urban traffic. It makes the chassis inherently twitchy and sensitive to steering input at highway speed. Second factor is larger wheel diameter and gyroscopic force. Standard motorcycle wheel, typically 17 to 21 inches, act as heavy gyroscopic at high speeds, which keeps the bike locked into its lane and stabilizing it through high-speed sweepers and curves. In case of scooter, the small wheel size generates significantly lower gyroscopic force at speed. This makes the scooter far more susceptible to being pushed around by side winds, air turbulence from large tracks, or minor road irregularities. Third factor, stability under load. Two-up touring. In case of motorcycle with rigid diamond parameter or trellis frame, connects the front steering head directly to the rear swing arm. This prevents chassis flex when leaning into high vehicles under full payloads. Obtain this central engine placement and balanced luggage mounting keep the front wheel planted, ensuring precise steering feedback and traction when cornering at speed. Let's have a comparison. Number one, wheelbase geometry, extended wheelbase in case of motorcycle, and short wheelbase in case of scooters. Gyroscopic force high in motorcycle and low in scooter. Chassis rigidity high tensile perimeter trellis frame prevent high speed flex. Scooters step through open frames exhibit flex under heavy speed or heavy loads. Cornering stability high in case of motorcycle and low and moderate in case of scooters. Is the infographic explaining the sim items that is gyroscopic force, chassis rigidity, cornering stability, and two-up touring. Motorcycle longer, stronger, and more stable. Scooter shorter, lighter, and less stable. Now coming to the last factor, and that is lower purchase cost and wider model choice. Motorcycles are generally available in a wider range of prices, styles, and specifications, affording better affordability and more options for different riding needs. Motorcycles, they have their global production volume is massive. This huge economy of scale allows manufacturers to offer entry-level basic commuter bikes at extremely low price points, as well as mid-range and high-end models for every budget tier. Scooters. Scooters often carry a higher starting price than basic entry-level motorcycle in the same displacement class. Coming to the second point, that is category and style diversity. Motorcycles span a vast spectrum of specialized categories, allowing riders to pick a machine tailored precisely to their riding style and terrain requirements. That is, cruisers, classic, dual sport adventure, naked commuter, and sport tracks. Scooters, by contrast, are primarily designed around the step-through commuter blueprint. While variation exists, such as maxi scooter or adventure-style scooter, the overall structural formula remains more or less uniform or far more uniform. Coming to the third element, price to performance ratio related to the lower price purchase cost and wider model choice factor. Dollar for dollar, motorcycle generally deliver better mechanical specification for the price. At an entry level, motorcycle often provides larger wheels, dual channel ABS, a manual gearbox, and a stronger chassis at a price point where a comparable scooter might only offer a basic rear drum brake, single channel ABS, and smaller wheels. Finally, the comparison related to lower purchase cost and wider model choices. Starting price, motorcycle very broad, scooter higher entry floor due to complex plastics and CVT mechanics. Model category options, extensive in case of motorcycle, that is cruisers, ADV, naked, sport, dual support, tourer, and scooter concentrated, urban step through maxi scooter that is limited. Back to price ratio, high in case of motorcycle and moderate in case of scooter. Market customization, massive aftermarket and multi-segment choices. In case of scooter, focus primarily on urban commuting utility. Here is the infographics related to the factor 21, that is lower purchasing cost and wider model choice, containing features like starting price, model category options, spec to price ratio, customization, and aftermarket. Motorcycle, more choices, better value, your pride, and your way. In case of scooter, fewer choices, higher cost, and limited options. With this, we conclude our discussion on the subject of motorcycle versus computer, the final verdict, part 3. Stay tuned to watch the similar videos on the subject related to automobiles, motorcycles, scooters, and auto rickshaws. And if you feel appropriate, please do subscribe this channel. Thank you and thank you very much.